Okay, so it's day 5 and today we are going to discuss about full adder using half adders. So in the last class we discussed about the full adder, and in that I mentioned we can design full adder by using two half adders and one OR gate, right? So today we will see how we can use those half adders. So let's discuss. So this is the circuit diagram for full adder, and okay, we already discussed about the half adder, right? So in that we have two inputs, and those two inputs passing through this XOR gate, that is sum, and for carry those two inputs passing through the AND gate, right? So this part of the full adder, it looks like half adder, right? So this is one half adder and this is another half adder, and here in the full adder we have three inputs. So this A and B is passing through this first half adder, and the sum of the first half adder is going as an input for this second half adder, one input, and second input is our C in, right? And similarly carry of this first half adder is going in this OR gate, right? And carry of this second half adder is also passing through this OR gate. So this first half adder carry and second half adder carry is input for this OR gate, and then we will get uh, carry out C out for this full adder, right? So sum we are getting, full adder sum we are getting from this half second half adder sum, and carry of this full adder we are getting from this OR gate. Okay, so we will use gate level modeling, and we will write Verilog code for this full adder by using half adders. Okay, so let's move to the coding part. So in the full adder we are using two half adders, right? So before moving to the full adder Verilog code, we need to write Verilog code for half adder. Okay, so here I have written Verilog code for half adder. Module name is HA, and these are the inputs A, B, sum and carry are the outputs. Okay, so input, output, and here for sum A XOR B, and for carry A and B. So this code we already discussed in our half adder Verilog code video, right? So here is the half adder Verilog code. Now let's move to the full adder Verilog code. So here is the full adder module. So module name is FA by using SA. So I just wrote FA dash HA. Then these are the inputs A, B, C in, and these are the outputs sum and carry. So input A, B, C in, and output sum and carry. Okay. So as we are using gate level modeling, and our diagram is this one. So this output of this half adder means sum of this half adder is input for this second half adder. One of the input for the second half adder, and other input is C, right? And here carry of this first half adder is input for this OR gate. Okay, and here carry of this second half adder is input for this OR gate, right? So here this line, and this line, these are acting like a wires, right? So this is output, but this is output for this half adder, but coming as an input for this second half adder, right? Similarly this one, this wire and this wire, so we need to declare them as a wire. So that's why I wrote S1, C1 and C2. So these are the wires. Okay, that's why I wrote wire S1, C1 and C2. Why we are writing wires? Because this is the connection between the gates. Okay, and this S1, C1 and C2, they are not storing our data, they just pass from one circuit or one gate to the other gate. That's why we wrote wire. Okay, next, so we need to instantiate our half adder module. Here we wrote half adder module Verilog code, and now we need to instantiate that half adder module in the full adder. So that's why I wrote HA, then instance name H1, and input and AB are the inputs, and S1, C1 are the sum and carry for this first half adder. So let's see here. So see, this is the first half adder. Okay, so this is the first half adder, and AB are two inputs, right? And for sum output we wrote S1, and for carry output we wrote C1. Okay, so that's why S1 C1. Same A B S1 and C1. Now let's move to the second half adder. I wrote HA, then instance name H2. We are instantiating same half adder two times, right? So that's why we need to keep this instance name different. Now here these two are the inputs. Okay, S1 and C, and these two are the outputs. So let's see here. See, so for this second half adder, S1 is coming as a input, one of the input, and CE is the second input. So that's why I wrote here S1 and CE. Okay, and uh, uh, and output of the second half adder is sum and this carry C2. Okay, so that's why I wrote sum and C2. C sum and C2. So we need to write in this same way, like first inputs and then outputs. If we change this first output and then after that input, then we face some error. Okay, so in same see in this half adder module we wrote first inputs then outputs. Okay, so that's why we need to write here first inputs then outputs. If you change means you will get some errors. Okay, now next is for OR gate. So here let's see this. For this OR gate, our input is C1 and C2, right? And our output is Cout. Means carry out carry out for this for carry out for our full adder, right? So that's why we wrote. See here for this OR gate, uh, we can directly use this these gates, AND gate, OR gate, XOR gate. Those basic gates we can directly use here. No need to write code for that. Okay, so for this first output, then two inputs. Okay, our carry is the full adder output. So here output name carry, then two inputs C1 and C2. So this is the full adder code for by using gate level modeling and by using the two half adders and one OR gate. Okay, so try to write test bench for this full adder. Test bench is same whatever we discussed in the last video. That same test bench we can use for this code as well. And you just try to simulate, and you definitely you will get exact simulated result. Okay, so we'll discuss few more questions in the upcoming videos. Till that, thank you.